All right, guys. This section is pretty tough. There's a lot of random questions in it, but they're talking mostly about rate of change and slope in a lot of these. So rate of change just means slope. So which one has the highest slope? Let's see. You need to have the skill that you know that in equations, this is the slopes. The slope for B is 2. That for D, the slope is 5. Okay, so far D is bigger. Which one has the biggest? Now, we also need to know how to get slopes out of these XY charts, which is this one goes up 12, this one goes over 2, up 12 over 2 means the slope is 6. So far the biggest one is C. Now this graph over here really sucks, but you need to be able to get the slope from graphs. So let's see, this one, I don't know, like this one looks like it hits the box right there. I can't really tell where it hits another one. If this was 5 right here, I don't think it hits that box. I think it's probably going to hit the next box after that, right? That looks like it's going to hit even another box higher. So I think it would hit like this box up here, like if there was another one. So probably like up there. So let's see, where would that hit? That means this slope would be up 1, up 2, up 3, 4, 5, 6, up 7. And then over 1, up 7 over 1. So that's a terrible graph to put on a test. I would want them to know exactly where it hits, but it looks like it goes higher than that 6th box. So anyway, this one looks like it goes up 7 over 1, so I would say that this one actually has the highest slope of 7 divided by 1. That's a terrible graph to put on a test because it's hard to see. But what we do know is how to get slopes from graphs. We should be able to do that. How to get slopes from equations. How to get slopes from lists. So if you can do all of that, then you're going to be good, if that makes sense. All right, so this one was actually A, but that was a terrible question. B, linear. If I just get rid of the AR, just which one of these is a line, a straight line? Well, this one's not, it's curved. This one is not because we haven't talked about these this year in class, but we've been doing y equals like 7/8 x plus 5. We haven't had powers. As soon as you throw powers on the x, it turns the graphs from a straight line into weird curved lines called parabolas. So if you ever see a power with x, not a straight line. It's something that kind of looks like that, so not a straight line. We haven't talked about that much. All right, but we have talked about how to get like, normally we write them like this, the x and the y. So we have the 2, 5, 8, 11, -5, -1, 3, 7. Okay, this is how, in a straight line always stays straight. So if it goes like up 4 over 3, up 4 over 3, up 4 over 3, it's always the same slope everywhere. So we have to see, like, if this is a straight line, no matter where I do, I should get the same slope. So this is up 4 over 3. That's why I said it. Up 4 over 3. Same slope. Up 4 over 3. Good. So this is a straight line. If it ever were to change, like if this was like 5, then it's not a straight line. But they could try to trick you and do like, what if they said like 15 and 17? Like this one goes up 8 over 6. Well, 8 over 6 is 4 over 3. So all they did was skip a point in there, but that is still a straight line because it's the same slope. So in a straight line, it has all the same slopes. So this one is a straight line. Number 3, you just have to see, like, here's an equation where you take x and you multiply by -5 and then you subtract 7, and that's what y is. Each one of these points only works in one equation. For this one right here, this one only works in this equation. Because if I take x and I plug it in, and I plug in the y so 6 is the y, 3 times 5 is the x, minus 9. Does 6 equal 15 minus 9? Yes, it does. 6 equals 6. So this one only worked for this equation. It didn't work for any other equations. All of these other points only work for one of those equations. Can you figure out which one it is? Each point has an equation that it goes with. Okay. Number 4, same thing over here. I can pick any points. I can pick 6, 31, negative 31. I can pick 10, negative 51. Any of these points, right, should go with an equation. So maybe I'll pick 10, 51, and I'll try it over here. Let's see. Does negative 51 for y equal 8 times 10 for the x minus 5? No, it does not. Negative 51 doesn't equal 80 minus 5. So nope, it is not that equation. Maybe I think that this one is this equation. Let's see. I'll plug in negative 5 times 10 for the x, and I'll put in negative 51 for the y, because that's what this point is over here, minus 1. Negative 51 equals negative 50 minus 1. Oh, yeah, it is this one. So this equation goes with these points over here. But you got to figure out which ones go with which other ones. All right, number 5 is actually very tough because you guys aren't good at using fractions. So I'm going to use this equation, y equals 7x plus 7, and I'm going to plug in 15 and 3/4. 15 and 3/4 for x, or for y, equals 7x plus 7. Now, one thing I'm going to do is I'm going to turn 15 and 3/4 into a mixed, or into an improper fraction. So that's 15 times 4 is 60 plus 3 is, this is 63/4 equals 7x plus 7. Okay, I'm going to subtract 7. 7 is 28/4. No, you know what? Yeah, I'll do it this way. So when I subtract 7, I get 63 minus 28 is 35/4 equals 7x. I'm going to divide by 7, which is multiplying by 1/7, and I get 5/4 equals x. 1 1/4. That's pretty tough. That's pretty tough. Now, doing it the other way, for the next one, y equals 7x plus 7, but we're going to plug in 2.5 in for x. Y equals 7 times 2.5 for x, or 2.5 plus 7. Y equals, what is that, 17.5 plus 7. Y equals 20, what is that, 4.5? 24.5 or 24 1/2. All right, tough problems. If you can do the next two, good for you. You should be able to do this one. That one should be pretty easy. Yeah, see if you can figure out that next one. It's just working with fractions. I know you guys aren't good at it. I'll show you in class, but give yourself a try. All right, number 6. Consider the function represented by this table of values. Which function could have produced the values in this table? So this XY chart goes with which equation down here? Now, one thing I can try is I could try every point in here and plug it into this equation and see if it works. I can plug in that equation in there and see if it works. Or I could do something else. Remember I said, if you know the slopes, you know something. This one goes, let's see, this one goes down by 8. This one goes up by 1. So it's negative 8 divided by 1, which is negative 8 is the slope. So when I look at these ones, this one has a slope of negative 1. This one has a slope of positive 8. This one has a slope of negative 8. This one has a slope of positive 8. The only one that has the slope that I'm looking for is one of those. Which one is it? All right, 7, enter the rate of change, enter the slope. Now, I like to write it sideways just because that's the way we've been doing it. So in my X column, I get 3, 6, 9, 12. In my Y column, I get 19, 13, 7, 1. And the slope, okay, this one goes down 6. This one goes up 3, negative 6 divided by 3. You should be able to tell me what that is. All right, select all the ordered pairs that satisfy the function y equals 8x plus 3. So do these points work in this equation? That's all they're asking. Do these points work in this equation? Let's see. So this is just go through and check. All right, let's see. Does negative 29 equal 8 times 5 plus 3? Because these are my x's and these are my y's. I just plug them in. Let's see. Does negative 29 equal 40 plus 3? No, it does not. So this one doesn't work. I could try the next one. Does 43 for the y equal 8 times x, which is the 2? 8 times 2 plus 3. Does 43 equal 16 plus 3? No, it does not. That one doesn't work. All right, I'll try 27 for the y. Does 27 equal 8 times the x, which is 3? 8 times 3 plus 3. Does 27 equal 24 plus 3? It sure does. This one works. And the last one, does 19 equal 8 times the x, which is 3, plus 3? You should be able to tell me yes or no. So when it says select all pairs, you just plug them in, see if it works. All right, number 9. 3 different linear functions are displayed in 3 different ways. Select the function that has the greatest rate of change or the greatest slope. Okay, we should know where to find the slope in the equation. Boom. We should know how to find a slope in a list. We've done it enough now. Let's see, 7, 12, 17, 22, negative 39, negative 64, negative 89, negative 114. All right, let's see. This one goes down by, how much does that go down? Is that 25? Down by 25. And this one goes up by 5. So negative 25 divided by 5 is negative 5. Okay, so this one has a slope of positive 4. This one has a slope of negative 5. This one has a slope, this one's going, kind of looks like it goes from there to about there. Down 1, 2, 3, 4, 5, 6. Down 6 over 1. So this one has a slope of negative 6. Okay, so this one has the greatest rate of change. This one has a slope of positive 4. It's the biggest change. That being said, does it matter positive and negative? I don't think it does. This one's positive 4, so that one's the biggest rate of change, I think. Or is it the absolute value? I'm going to have to go back and check. But yeah, A is 4, B is negative 5, C is negative 6. Let's see. Select the graph that matches this equation. This probably looks confusing, but let's see. Here's the slope, right? Is the slope going up or down? It's a negative. So which of these lines is going down? And which of these lines shows that they start at negative 3? Let's see. This line is going up. This line is going up. This line is going down. This line is going down. So we know 2 of them are already eliminated. This line starts at 0. This line starts at like positive something. This line starts at positive something. This line starts at negative something. Which is the only one that matches the slope and where it starts? It should be kind of easy at that point. All right, good luck. See you tomorrow.